and welcome everyone. Thank you all for joining us today for this live stream event. My name is Rebecca and I'm the event planner of the Microsoft Reactor New York. We will be sharing session resources with you momentarily in the chat, but before I begin, I'd like to quickly review two items, our code of conduct and event guidelines. So for code of conduct, Microsoft Reactor seeks to provide a respectful environment for both our audience and our presenters. We encourage engagement in the chat, but we just ask that you're mindful of your commentary, remaining professional and on topic. This session will be recorded. It will be available on demand through the Microsoft Reactor YouTube channel in about 48 to 72 hours. I'll share the link to in the chat for the YouTube channel momentarily if you're not familiar, if you're tuning in for the first time. If you have not been on a live stream before on YouTube, just note that to access and interact in the chat, you do have to have an account set up. So now would be a good time to do that if you haven't done so already. Which brings us to today's session. Let me bring up our speakers here. Hang on a second. Hello, welcome. So the Reactor is joined by Ornelia and Alfredo today to introduce you to MLOps for IoT devices. The session will run for approximately 60 minutes, and you can feel free to drop questions throughout. Hi, Alfredo. Hi. Ornelia, feel free to unmute.
Hello. Thank you so much for the introduction, Rebecca. Hi, Ornella. How are you?
Hi, everyone. Thanks for having us.
Welcome all. Let me pull up your screen here. Did you want me to share that yet, or?
Yeah, actually not yet, because I wanted to have a short introduction with Ornella. So I'm gonna stop sharing there. Sure. Hopefully that's okay with you, Ornella.
Yeah, totally.
Yeah, so this is excellent. Thank you so much for being here today. It is exciting to talk about MLOps, trying to figure out what that is. There's always, it always feels like a buzzword, like latest buzzword that we need to find out what it means and if it's even useful at all. So it's good to have like certain notions about what MLOps is and what can we do about it. What have you heard about MLOps, Ornella?
Well, the answer is not much.
Yeah.
But feeling very grateful to be in the same room as, the person who wrote the book on MLOps. So I'm sure you have a lot to teach me.
Yeah, well, I mean, that's part of I would say part of the problems I think with technology today is that people are starting to throw terminology left and right, and then we're like, what does that mean? And then suddenly we're like, oh, this just means X, and like, oh, this is great. I was, that once happened to me. I was interviewing at this very big, large tech company, and one of the interviewers said, "Hey, do you know about closures?" And I was like, "Closures?" And I was like, "Yeah, no, I have no idea what closures are. I'm a Python developer, and I thought this person was asking me about something that was not Python."
Yeah.
And I had no idea what closures were. Have you heard about closures?
No, couldn't tell you.
All that a closure is, it's a function that is declared or written inside another function. That's it. So it's like you write your function, and then inside you say, well, I'm going to write another function in here. That's it. And I was like, why didn't you say it was a nested function instead of like, ooh, let me throw something fancy?
Why do they have to give everything such a complicated name? I mean, not even the name is complicated, but just like the terminology is not common or useful.
Things like that happen all the time, I think, in MLOps and DevOps and all of this stuff. They start sounding like like very it sounds like a buzzword, and in sort of ways it is kind of like a buzzword. But the idea here today is to yeah, that's right, Tyndall. Like, why call it EC2? It's virtual machines. Yeah, well, that's a little bit of branding. MLOps is more of like a general term, but the thing is, and what I want to concentrate today on is that we're going to go through the steps of interacting with a trained model. Like, I'm going to use an off-the-shelf model, and then go through some of the steps on getting that working locally. But we'll explain as I go through. Like, I'll certainly get into trouble and get into things not working, like a normal software engineer would do. Like, you should be very suspicious if you sit down, you start writing everything, or you actually see a demo of someone sitting down, writing everything, and everything's just perfect. It's like everything works. Like, that's have you ever written anything, Ornella, that just like you sit down and write code for like an hour and everything works?
I mean, there's definitely a moment of prayer where you wish that's true, but the amount of times it's actually happened feels very small.
So there's this misconception that, you should write perfect code all the time because demos are perfect. Like, I not intentionally, but like all of my demos, I tend to get into trouble and get into things like, well, I don't know how to fix this, so I'll have to figure it out. And that's kind of like the thing here. And with that, I would say the premise of MLOps is, or the foundation of MLOps is automating processes. It's very similar to DevOps in that sense, where we're gonna go through the manual process of like trying to set things up and see what can we automate for that so that we can make our lives easier. And how does that relate to IoT? Well, it doesn't explicitly deal with IoT, like, oh, this is only happening for IoT devices. But I'll tell you like one big difference that I was actually struggling while I was preparing for today. We are often sold on the idea that containers are solving the inconsistency between computers and compute environments. So my computer is probably not the same as Ornella's. Ornella, what computer do you have?
I have a MacBook Pro.
And this MacBook Pro has the Intel processor or the new M1 processor?
I think it's the old one.
The old one. So so right there, like we could say, well, containers could solve this problem because I have also an Apple computer, but a container built in my machine is probably not going to, or is going to have trouble with Ornella, because the thing is that containers are also architecture specific, or they could be. So you can have a container that is ARM64 and not necessarily Intel. And so we started getting into these inconsistencies where I probably could not build a thing that works for Intel machines, or like an Intel-based Docker container in my machine, because like I have an M1, which is the latest Apple silicon, which is ARM64 based. And so that's a problem. So the idea is to, like, how can we just press a button and have something built that it doesn't matter if it was built on my computer, but it can also be later deployed to an edge device. So we've for today, we have a few links prepared. We're going to talk just a little bit about a couple of sections, maybe one or two chapters from the Practical MLOps book from O'Reilly. This book has tons of content on MLOps, but specifically has a section on deploying to IoT and edge devices. One of the problems of IoT and edge devices is kind of like what I described with the different computing environments with Ornella in this case. And that is like, hey, like if it works on my machine, it doesn't, even if we're talking containers specifically, it might not work on someone else's machine. So trying to set these things in an automated way. So yeah, let's go ahead, and I'm going to share my screen. I'm going to start typing away at my terminal. And
I am, I don't know. I think there's a slight issue in that our student ambassador community doesn't have the link to this. So I'm just trying to find the link to the live video so that I can send it to everyone. It looks like some people found it, but I think some people are still having trouble. Yeah, just 1 second.
Hey, yeah, it looks like possibly the wrong link was put in some of the registration pages. So I've been messaging them. So I just dropped it into the private chat. So if you don't mind sharing that, sorry about that.
Yeah, so it's not like this session is super special only for for a few people. Like I guess we yeah, thanks. Wow, thanks for joining.
It seems like people are finding it. Okay, great. Welcome to our student ambassadors. Sorry about that. That was kind of confusing.
Apologies. Yeah.
Yeah, a bummer that we went through a little bit of the explanation beforehand. But one thing is worth repeating though, that this is recorded, and once we're done, you can go back and watch the intro. If things are not quite clear, like why is Ornella discussing this with Alfredo? It doesn't make any sense. Where are my IoT devices? Well, I actually have an IoT device over here. This is great. Well, not strictly an IoT device, but this is a TPU, USB TPU device that you can just plug it in, and you can do inference with a TPU over USB. And certainly you can train things that work with that. But we're not going to be deploying an actual thing onto an IoT device today, but we'll talk about the foundations of MLOps and how that we can apply that to IoT devices, or anything really. Like a foundational thing allows you to really apply these concepts to anything. All right, so I'm going to share my screen, and I am going to use my browser over here. So I think, yeah, perfect. Thanks, Ornella. So this is one of the repos that we're gonna be looking at, and essentially, I'm gonna walk through what it is, and just very briefly to see what are the components of the things that we're dealing here. So we have, unfortunately, whoever wrote this README is not very good because it's very succinct, and sometimes you might encounter problems with people not documenting their things or their projects very well. So that's okay. We're gonna walk through it and see what this thing is about. First, let's just go about the functional part before we get into containers. What I like to do, and Ornella, perhaps you have like a different view here, but I try to make something work manually and see, like, just make it work on my system, and let's see if that then, like, if I make it work in my system, then we can proceed to automation and containers. Do you have like a way of like a type of workflow that you use when you're tackling a project like this?
Well, so can you talk a little bit about what packaging means?
Yes, because this person wrote here that there's packaging involved, and it's like, what? So we were telling a story right at the beginning about fancy words for simple things, and when I started looking into packaging for machine learning, all that it means, and this is going to sound very surprising, all that it means is that we're going to put a model into a container, and then that's it. That's your packaging right there. You're copying a file into a container, and
it doesn't even have to be like your own model. It can just be
anything,
a pre-made
today,
model. Yeah.
You see, like, and so people are saying, well, we're gonna do some packaging work here. It's like, you better know your stuff. It's like, no, we're just gonna copy a file inside a container, and then that's it. And actually, where you can see these. This will happen here in the Docker file, but I didn't want to get into the Docker file yet. But you can see here that on line 11, we're going to copy this sequence classification model that we're going to download. Or I pre-downloaded it because it's pretty large, but I'll show you where that is coming from. So aside from the Docker file project, what we have here, it is just a very basic, extremely basic Python project that doesn't even have fancy modules or anything like these. We have a requirements file. It just declares what are the versions that we're going to work with today. These are the preset versions, and you can install them in a virtual environment. Actually, we're going to do that and see what happens. And then we have a directory called web app. The author was very inspired to call it web app, and it only has a single file here. Let's see how many hundreds of lines we're talking about. 44 lines, and this is it. So the bulk of the work will happen on line 32. Which is like the special instructions we're going to need to work with this model. This model is a sentiment analysis model called Roberta, and I'm going to show you. I think it is this one. Yeah, there's a repository. There's a thing called the model SU, and the model SU. Well, I'm full of these things, I swear. The model SU, it's a repository where you can find a lot of models specific to Onyx. Yes, that's all it is. And in this case, other places might have like a nice repository of packages and models. In this case, no, it is just a repo. And it is from the Onyx organization. If you have no idea, have you ever heard about Onyx, Ornella?
I had a friend who recently joined the Onyx team. I think I heard a little bit about it from her, but don't really know that much.
Yeah, so Onyx is really good because, or really interesting. I'm really excited about it because what it means, or what it provides, is kind of like a way where you can use whatever fancy framework you are comfortable with. So say TensorFlow, you're like doing your training, you have your data, and then boom, you're like, ooh, I want to have like a normalized way, like a way where I can grab this model and interact with it, even if I don't have TensorFlow or I'm not interacting with TensorFlow. So you can convert your model trained in a specific platform over to Onyx. And most of the popular frameworks allow you to do that. And also there's a few frameworks that allow you to go from Onyx to something else. So it kind of like provides like a bridge where you can say, oh, this thing is, the fancy word for it is interoperability. So you can interoperate with many different frameworks that are training, you train models in a very specific way with very specific frameworks, like TensorFlow. The way you do it in TensorFlow is not going to be the same as PyTorch, and so on. So this is very exciting because it provides you like a normalized way of doing that.
Yeah, so very cool.
The model SU is this directory where we're going to have this repo where we're going to have a bunch of different models. And here we are in text, machine comprehension, and down to Roberta. And I'm going to click here on Roberta so we can go one step above. This is really crucial for MLOps stuff. I'm going to see why. So I'm going to scroll down here. It gives you a brief description what BERT is. BERT is kind of like the building block for Roberta, and it tells you a bit of information. Now, this is very very important because it's giving you details about the model. So in this case, what we want to work with is the Roberta sequence classification model. It's 499 megabytes, which, by the way, it is not possible to store on GitHub. And we'll see how they managed to provide a link here for 500 megabytes of data.
Wow.
Yeah, so so don't try to push files that are that big on GitHub. It won't work. So here's an important. Oh yes, let me see if I can get you that link. Yeah, sorry, I forgot to talk about that link. There we go. So so what we're doing here is we need to catch the Onyx version and the offset version. Why is that important? Well, what do you think would happen if I build this project and then deploy it, and then there's a bug, and then Ornella gets assigned to it, and I didn't put any versions or offset versions or anything? She would have to figure out what does she need to install to basically work with this thing and rebuild it. Like if she needs to rebuild a container and Alfredo forgot to put a requirements.txt or a README that has this information, then we're toast. She would have to like, oh, let me try with 1.5. Oh, that doesn't work. Let me try with 1.4. Oh, that doesn't work. Let me try with 1.6. Oh, that works. So I could make her spend like hours.
So I get the Onyx version part. What does offset version mean?
Very good. So that's an excellent question. So the Onyx version might not change, but the offset version is what arguments, in a way of speaking, what arguments does the model work with? So a difference in offset means that how you interact with the model might be changing. So the framework might be the same, like it hasn't changed, but the model has changed in how you're operating the model, what are the inputs are looking like, and how to basically interact with the model. So if that changes, then your Onyx version might be great, but you'd be like, nah. And certain models have support for certain offset versions. And so this is critical, because you can't, like if you have this in production, you have like, Ornella has this cool startup and she has this thing deployed and everybody can submit phrases onto this device and get sentiment analysis, and suddenly we need to upgrade and we don't know. We just don't know what to do there. So that's
the
problem.
Two kind of key things you're going to need to tell someone if you're working with models in Onyx is probably the Onyx version and also the offset version.
Yes. Yeah, absolutely. Okay. And I think with anything, the more comprehensive, the more information that you can provide to any project that you're building, the better. Like if you're properly documenting exactly what's going on and what versions you're using, aside from a requirements of text, well, in this case, it's a Python project, but it could be absolutely anything else. And then we get into some of the details here on how to do the conversion, and the conversion not really, but that's the script that was used to. You can see here, Ornella, what we were talking about. The script that was used to export the base model into Onyx. So that's always useful. But the pre-processing is where all of the useful stuff is coming from. The thing that I show you in my repo is using these so that we can kind of like deal with the sentiment analysis. So this is also good because you kind of have like a good sample on how to get started, and then it tells you, hey, like the sentiment was negative or it was positive. All right, so that's what we're going to use. And
so those are the two. This model will only give you one of two predictions.
Yes, it will either tell you like this thing is positive, it has a positive sentiment or a negative sentiment. So, and it will give you a little bit more of information here, validation accuracy and all kinds of information. But I'm going to scroll all the way to the top, and then if I click here, it's 499 megabytes, and you can see that there's this message stored with Git LFS. So what that means is that it's bits and pieces of the file has been spread over in Git into multiple different repositories, and GitHub has this ability of working with Git LFS and try to provide like a single point for downloading. So if you click download, it will download the 499 megabytes, but it is not possible to save that file onto GitHub. So that's a big problem if you're dealing with large models. So in this case, it's 499 megabytes. What if this was like 10 gigabytes? Like it's just not gonna work. So things that you need to keep in mind. All right, so this is the thing that we're going to work with. And let me see if Thindel has a question. It is, isn't that what Microsoft built to be able to handle the Windows source code in a GitHub repository? Because it was like a terabyte. Maybe, I don't know the whole story behind Git LFS, but maybe it was, but definitely yes. Yeah, perhaps just Git. You know, it is entirely possible. Large files are a problem. I would say that there are better ways to store models into something not Git. So platforms like Azure. Has they have like the machine learning studio where you can register models and you can version them, which is great. You can build your 1 gigabyte model and push it over to a model registry and get it versioned.
I'm back. Sorry, I don't know what happened. I think my internet just dropped.
It's all good. We're happy you're back. We were just talking about what to do with models that are ginormous, and I was explaining that we, like put it in on GitHub or on a Git repository. It's probably not a good idea because it can be so large. And
yeah, so this one uses Git LFS.
Yes,
is that what it's saying?
Yeah, because it's so spread over many different spots. But
yeah,
if you're doing this in production, what you want is a model registry, and platforms like Azure Machine Learning Studio have like a place where you can put a model and version it, which is huge. Going through different versions, like, oh, Alfredo broke the build, and then Ornella is like, oh, let's go back to the previous version. That's part of MLOps as well, because we're putting ourselves in a spot where we can roll back to a previous version, which is it's easy to think about versioning when writing software, but machine learning is still trying to keep up with the pace of doing best practices.
A fun fact about Git LFS is that if you've ever used VS Code and looked at the VS Code documentation and tried to contribute to it on GitHub, you'll see that they also use Git LFS to store all of their images, because there's so many images in that repo and a lot of them are really big. So they also do that.
Wow. Well, I had no idea about that. But I think that's a perfect use case for something like Git LFS.
Yeah.
But certainly, if you're for machine learning, there's a better way of doing this, and it's not through Git. So all right, so we have our Roberta sequence classification, which I pre-downloaded, and now if I go back to my repo over here, you can see here that is basically the kind of like the same thing. The code that uses the TensorFlow and the tokenizer, they're not very easy to read. Actually, it's just kind of difficult API to deal with. But the idea here is that we have a /predict, and then we can submit post some text, a phrase, and this thing will receive it. You can see here that it uses on line 35 body that phrase. That's the stuff that we're sending, and then it will read that, and it will go through the sentiment analysis, and then it will give you a result, which is the out on session.run from the inputs on line 41. And then we'll return some JSON saying, hey, is this positive? And we'll give you a true or false. All right, so that's it. So let's try to build it. Let's try to
let's do it.
But I swear that there's high chances of these being getting into trouble here. All right, so we have here the repository. So we have the Docker file requirements, the web app is exactly the same. This is my terminal. I've pre-downloaded the Onyx file because it's pretty large.
Yeah.
So if I do ls web app, you can see there the Roberta sequence classification -9. It's there. It's good to go. And so the first idea is to try and make it work locally. You can see that there's a VM there. In order to save some time, I've pre-installed the requirements. But the idea is that you would do something like Python 3-m VM.
So you're activating the virtual environment.
Yeah. Unfortunately, Python has horrendous packaging and is very problematic and is very tricky to get right. And even if you're super experienced, you can get into trouble. So the thing here is that you create this virtual environment. Well, it's kind of like a container, a directory will have all of your packages. Then if something goes wrong, you can just remove it, and then that's fine. Python 3 comes with a module called VM, which you can access via -m, and then the module name, which is VM. And the argument that you can provide to this call is the name of the virtual environment that you want to create. It will produce a directory. So in this case, it is, I'm calling it VM. And once you do that, I'm going to Control-C out of that. Once you do that, a VM directory will be created. So if you do ls VM, you'll have bin, include lib, and all kinds of things that you should not worry about it. All that you need to know is that things will go in there, and instead of your regular system Python installation, and it will not mess everything up. And then once you do that, then you need to activate this virtual environment. The way to activate it on Linux and on OS X is source em bin activate. And you can see that now this has changed, and there's that's a telltale parentheses
that means we're in
and then
it.
the name. Yeah.
Yeah.
I'll have to check. I don't know why I am not. I think I'm running out of battery. Give me 1 second. I think I need to double check here why. Give me 1 second, or no, I'm just gonna mute myself, and you can
totally.
You can help me out here for a second while I try to plug this in.
Yeah, I think if folks have worked with other, virtual environments so far, should be pretty similar. I think the thing that Alfredo will show us is the really cool application of this is just the part where you can literally take a machine learning model and put it into this environment. But if you've already worked with virtual environments in the past, this should be a pretty standard kind of setup process. Are you going to talk about the requirements next, Alfredo?
Yeah, that's right. So sorry about that. I had to plug this thing in. It's this is the problem when you have too many computers and several monitors and all kinds of cables. This thing was plugged in the wrong thing, and I could see my battery running out, and we don't want this battery to run out before I finish creating this thing. All right, so Yeah, so you activate this thing. Visual Studio Code, by the way, automatically detects if you have virtual environment in the current directory or in several other normal or common locations, and will just say, hey, do you want to activate this? And you'll say, yes. Oh, here we go. So it's pretty wonderful. But I'm not using VS Code today because this thing here is a remote. This thing is a remote server, and I didn't get time to make SSH work seamlessly here, so that we could run VS Code with a remote compute instance, which is actually something that you can do and is pretty useful. All right, so VM is activated, and one thing that you can do to verify is you do which, and you can say Python, and that tells you, hey, Python is coming from this path. So this is great because it's telling you like that's coming from the virtual environment, not from somewhere else, and that's how you confirm things.
Wait, I didn't know that command. That's so useful.
Yes,
that
which will tell you
so
like which is perfect because it also tells you like if things are installed, like an executable is available. So if you do which Alfredo not found. Like, where is he? Well, he's pretty busy right now, but not available as an executable. So he's not there. So which is pretty useful. Or, you can say, yeah, I think which is kind of like what I tend to do. Like, and if it's a specific module, you can do Python. Can we move the
yes,
so that we can see the terminal? Yeah, perfect. So one thing that you can do is say import Onyx, and then you can say print Onyx with parens, print the module, and it'll tell you exactly where that module is coming from. So in this case, it's coming from the virtual environment. So that's another trick that you can do there to verify where is this module coming from. And so what I've done here is I've used pip install -r requirements.txt, and I think this was able to complete. I'm going to run it again, but it's just an enormous amount of packages and output, and it's always giving you warnings. I don't know if I'm doing something wrong. No, it's just a warning. So the thing there is that we have everything pre-installed and ready to go because we're running out of time, and I didn't want to spend 10 minutes looking at how this thing downloads and installs like a gazillion million packages, because we have requirements.txt that only has 5 things in there, but the dependencies are through the roof. And yes, Peter, that's good. Yes, a nice feature of VS Code is that it will detect these and automatically activate that. That's right. Okay, so now let's look at that Docker file, because the Docker file is kind of like, it's going to hint at us like how do we run this thing? What do we need to do there? So it copies the requirements. That's fine. Work there. And then installs. This is how it builds the container. Installs requirements.txt, which I've already done. It copies the content of web app into the container, and then it copies the Roberta sequence classification model into web app. And then it runs this thing called Uvicorn, which is something provided by Fast API. We're going to use Fast API here, which is just really like a tiny framework that allows you to serve this over HTTP. That's the whole thing. That's all packaging. It's like we're slapping a nice web framework that will allow us to receive requests. So that's how we're going to interact with these. So what we're going to do, we're going to go to web app, and then we're going to run Uvicorn. So if I wanted to say which Uvicorn, it tells me where it's coming from. So
I'm not over this feature. That's so great.
Yes, it's very useful. All right, so it says host. We're going to do 0.0.0, and then we're going to say main app. Why we're using main :app? Because in our main.py file, we have the app function, and that's just the main hook. So I'm going to run these. And it's going to take a second because it has to load a 500 megabyte model into memory.
Wow.
All right, started process and running at 0.0.0. And what I'm going to do is I'm going to go here and then go to my, here, I'm gonna go, let me see, this button, yes. So I'm going to do, this is a remote server running locally, and that's 192.168.0.200, and it's port 8000. So if I run that, you get a self-documenting API. So this is great. It is running. I haven't done anything actually. Because it's mainly a JSON API. I think it's box. Yeah. Woo! Look at that. So Fast API is pretty amazing because it gives you self-documenting API, and you can see here that you get the root and predict. So it's already grabbing all of my functions there, and it's automatically documenting them. Now, developers tend not to like documenting and sitting down and writing documentation. And but although this is great, you should still take care and write nice human readable documentation. So if you have like, oh, I don't know how this model works, and it tells you like request body, how does this thing going to work? Look at that, you get an example value. Not only that, it gives you the a thing that how are you supposed to what are things that, or how these things would look if you're getting some error. So you have here an example value, the request body, and then you can say, oh, I want to try it out. And you can execute these. And you're going to get two things, well, several things that are very, very interesting. First is you're going to get the curl command. And I forgot about this. And while I was preparing for this, I was like, how do I do this with curl? And it's like, I could not remember how to do it. And here you can just basically come here and say, I want to copy this, click this button over here, and then just run it on the terminal, and it will work. But we don't need to go to the terminal because we're having exactly what we need here. So the request URL is /predict, and you get the response was positive equals false. So we need to see if we can we can change these. How about we say the reactor has useful content, and then we can try that. I'm going to execute, and you can see here that the request has changed. Actually, I'm going to make this a little bit bigger. I think it's kind of small. There we go. One more. So now you can see positive change to true, which is great, and we can change it back to something else. Let me see. Alfredo writes bad readmes. We can say execute, and we can play here and see, see positive, false. This is not positive. This is just very negative. And we're
Alfredo.
So yes, Swagger is great. This is all Swagger based, and it's self-documented with our friends from Fast API. So what does this have to do with IoT? Well, we're trying to build this thing. We're building blocks, and then we're going to build a container. So I'm going to go back to the terminal. We now know it works. You can see all of my requests are there, and I am going to Control-C out of that. And I'm going to go one directory app, and then we're going to do, I think Docker is still available in this machine. It is. I'm going to say Docker build dot means like the current directory. And I think that should work. So let's see. So we are getting into trouble because we don't have Python 3.8, and we can't load it up. So that's kind of problematic. So let's take a look at our Docker file.
Does that mean you don't have it in the right environment, or?
Yeah, so that's probably it. But like, I don't know. Let me see, Python version. I do have locally Python 3.8. So perhaps, let me see, unknown description, credentials. Ooh, so this means that that I, since this is not necessarily a server, I'm going to copy paste this somewhere else. Let me see. So what happens here is that this is using Docker for like in a desktop. And so we can try this again. I think I might need to log in. So I might need to log into Docker, but let's just assume for a second that these builds, like, it's an authentication problem. But let's just assume for a second that these builds is not a problem, the container is up, and we're validating that it builds and everything's good. So we're getting into a lot of trouble here. Ooh, what is this Docker? Python 3.8 is not available. Alfredo forgot to log in to Docker, to the Docker for desktop. He didn't authenticate. What are we going to do here? We're facing an impossible situation. We don't want to get into this, like Alfredo takes vacation for a sabbatical for 6 months, and then Ornella has to deal with this crappy thing that doesn't work. So the great thing is that although it's good to validate your steps, these right here should never, ever be the way that you are actually deploying things into production. And this is the building blocks for MLOps. And very relevant to IoT devices. You would never want to have a model into production, into an IoT device, into an edge device somewhere that is built on Alfredo's computer that, who knows if this thing is working, like, do we need to update? Like, Alfredo is on sabbatical, we can't reach him, like, what are we going to do? Well, let me show you part of the automation that should go in here. So I'm going to go back to my browser. And I think it's here. Let's see. This is our application here. This is and I forgot to, let me copy paste these. I'm going to paste it here for everyone. Like, this is not necessarily part of what we've built today, but it's a similar concept. So we have here a GitHub Action thing. And what is GitHub Actions? Well, it's just a way of programmatically being able to just press a button or given a certain event or certain circumstance, like a timer or a schedule, it will build this thing automatically. So that's done with here in the first directory in .github/workflows, you create that. And then we have a build and a main. So we are going to click on main and go and see what this is doing. So this basically is a declaration of how this thing should work. It's not very long. I know it's YAML and people are like tired of seeing YAML, but it's just only 43 lines long. And all that is doing in this case, you will see it uses Hadelint. Hadelint is or Hadelint or Hadelint. So what it does is, like, it looks at your Docker file and looks like, ooh. So instead of Ornella reviewing my Docker file, we could just automate these, and I'm going to submit a PR, and Hadelint is going to detect things that I'm doing nicely or incorrectly in my Docker file. So that's really neat. It's automating part of the reviewer's thing that they would need to do. In the case if we're me and Ornella are in a production environment, if we want to make some updates to the Docker file, well, everyone, including me, I would like to know that the changes that I'm making are sound like. In LinkedIn is a huge part of code editors. VS Code, I think VS Code has the ability to lint Docker files as well, right? Ornella is like our expert on VS Code. She knows everything about it.
Not MLOps, VS Code, maybe.
But so far, I mean, we've been talking about containers and a little bit of linting and Python and requirements. This is all MLOps because we're getting into trouble and we're trying to define what is the strategy to get this out of this problem. So we're using here on line 33, we're using a specific GitHub action to start a build for a container. And then we're going to say on line number 36, we're going to start that build. And you can see the number 40 is the context, meaning like the current directory. Then the file is, you can have many Docker files. In this case, is the Docker file at the top of the repo. Don't push it. And the tags is going to tag my container with that. So this is just to see if it will build correctly. And that's why push is false. So that will give you validation if this is running on a pull request. So we can see here that if there's ever a pull request, this will try to build it and try to validate, hey, does the Docker file builds? Yes. Who knows if it doesn't build? Like in this case, I tried to build in my terminal and didn't build. So if Alfredo is breaking the breaking changes to the container, then that's a problem.
Come on.
So there are two files here. One is main and the other one is build. Come on. So the other one is built, and this one's the interesting one. So if you're, again, looking to see, well, okay, that's great. I have my Jupyter notebook and my terminal and my VS Code editor, and it works. We get sentiment analysis. We need to deploy this thing. Okay, perfect. Wait a second. Before you deploy, let's build this container and push it onto a container registry. So this GitHub action right here, let's just ignore the first few lines. We'll get to the good action here is that it authenticates to Docker Hub. So this repository has a couple of secrets. I've added my username and my access token into those secrets. And then I've created set up the build ID, which is a requirement for dealing with the Docker GitHub action. And finally, we're building and this is exactly the same as before for pull requests, but I'm saying push is true. So once it completes, once everything's fine, this will go ahead and push it and deploy it. So this is great because it allows you to have the confidence that a container with a model will be built, it will pass linting, everything will be fine. And at the end, we're not in a situation where someone needs to depend on me with my username and my token to try and upload something to somewhere else. And if someone is coming here and saying, well, like I'll tell you a story. It's also in the practical MLOps book where someone says like, oh, we need to update this container that is on Docker Hub. And I'm like, okay, great. Where's the Docker file? It's like, well, that employee is no longer here and we don't know where the Docker file is. So how do you do this? Well, in this case, this is why having a repository where you can see the Docker file. So let's take a look. Let's take a look at this Flask app Docker file. Okay, so it installed requirements and it just runs Python app.py directly. Nothing really weird. We can take a look at requirements. What is this thing doing? What is it? Ooh, only one requirement. This is fantastic. We can make a quick update and publish it, right? So you can see here, there's a couple of pull requests. We have something that was not good here. And you can see that there's a lot of things that fail there. And this is why, like, if Ornella is coming here and it's like, oh, Alfredo, like, this is just horrible. Like, we're not gonna merge these, and she can comment that and close the pull request on me because she's upset and she doesn't want to have these build super broken. How does that make sense to you, Ornella? Like, it's like, I know we're not into the guts of MLOps yet, but like this is kind of like foundational knowledge on automation. Does does this make sense?
Totally. I feel like I guess again, back to your earlier point, I feel like I knew all of these things separately. I didn't know that if you put them together, that was called MLOps.
Yeah.
Just in the last 5 minutes, do you want to touch on how exactly this ties into IoT, how we can use this for IoT purposes? Because that's what we're here to talk about. I think it's really important to have all of this foundational knowledge before we dive into the world of IoT, which is why we're giving this presentation.
Yes.
But yeah, can you talk a little bit more about that?
Yeah, so that's a very good point. So because someone that is watching this might be saying, well, Python, I mean, this is a web application, it's responding something over HTTP, but wait a second, like the foundational thing here, the essential thing here that is very pertinent to IoT and edge devices is we're talking about containers. And containers are going to allow you to have a way of building something that you can deploy onto, say, a Raspberry Pi or some other device and work in a very particular environment that is set just the way you want it. Like, oh, this is a container, it's Python 3.8 or it's Linux, whatever version, and then you're installing the packages. And we've taken kind of like there's always this thing where we're talking about shifting left, like this is very early, all the way to the left in the beginning of the process, where we're trying to figure out if something works, interact with it, kind of like build it and see if it works locally, and then setting some automation to create a container. So once you have your container, once you're happy with your model, once you're done all of your tests, well, you can use a platform like IoT Hub, where you can start controlling your deployments, and you can say, well, I want to deploy. Wait a second, how are you going to deploy a new version of your application? Or say in this case, we have a model and we're going to do some live inference over HTTP. Like, how do we get that onto these devices? Well, we're going to use a container registry, and we're going to use the same thing that passed. That passed all of the validations and that we just pushed because we released a new version. And I think that's kind of like the trick, because I think most people tend to think about this the other way around. It's like, oh, let me think about my IoT device that is in production. How do I get my thing there? Oh, yeah. IoT Hub and it wants a container registry. Let me create one. It wants a container. Let me put something in there. But wait a second, that's going to get you into trouble because that's not a repeatable process. It's going to, you're going to get there and suddenly you're going to want to make an update or realize that something's broken and you need to change it. And then you don't have those building blocks that allow you to press a button and have something already available as the latest. And you saw that I tagged my container as, :latest, but I could tag it with anything I like. And then you could say, how about, Alfredo, we don't go by the latest and we just version these things by date or something else. And then we could go to the previous container that wasn't broken, and then we can have like a more robust environment, IoT environment, where our deployments are not broken. And if they are broken, we can roll back. And this same thing you can apply to any environment where you're deploying containers and you're working with models. Like if you have these building blocks where you're automating your things, your models, your containers, your Python, your requirements, then everything should just work. So I think that's the key idea here. The foundational thing that applies to IoT is, hey, let's just automate these. It doesn't matter. I mean, this could be not Python. It could be something else. It could be some C, because I'm interacting with something else, some sensors on the, like, sure, it's in the end, like if you're going to do something like that, well, make sure that it works. Put some linting, put some automation.
Yeah. I feel like I learned a ton. I hope everyone else watching did too. Thanks so much for joining, and thanks Alfredo for being an awesome teacher. If you have any questions, everyone, feel free to reach out on Twitter. I think Alfredo also put his LinkedIn in the chat here. And yeah, we're happy to keep the conversation going and see what you create using all of the awesome stuff that Alfredo taught us today.
Yeah. Thank you so much, guys. If you are new to the Reactor program, feel free to check us out. We're on Meetup, Twitter. We have our own website, which is temporarily under construction. It's getting moved to a new location, so it isn't as interactive as it normally is if you are used to that website. Apologies again to anybody that tuned in with that link a little bit later. There was a little bit of a mix-up on the website posting, but we got it sorted. Again, this situation, the on-demand will be available afterwards on YouTube. So if you missed the beginning, feel free to tune in and just check that out. Alfredo, Arnelia, thank you so much. This was really great. I think this went really well. We had a great amount of people tuning in. Take care, all. Have a good one.
See you next time. Bye.